I'm going to repeat that. So we're solving quadratic equations using the quadratic formula. The quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. You guys might know the song. It goes to Pop Goes the Weasel. X equals negative b plus or minus the square root b squared minus 4ac all over 2a. Now you guys sing it. Can't hear you. So here's an example I'm going to propose. It says x squared minus 5x is equal to negative 6. With quadratic equations, they need to be in standard form. So part of the procedure would be put the equation in standard form. So putting the equation in standard form means setting it equal to 0. You know, ax squared plus bx plus c equals 0. So we're going to have to add 6 to both sides of the equation. So I'm going to have x squared minus 5x plus 6 is equal to 0. And then what you want to do is you want to identify your a, b, and c coefficients. A is negative 1 because we have a leading coefficient of 1 here. B is negative 5. We always include the sign here. And C is positive 6. Once we identify our A, our B, and C coefficients, we could substitute these values into the formula. So everywhere there's an A, I'm going to put 1. Everywhere there's a B, I'm going to put negative 5. And everywhere there's a C, I'm going to put 6. So I substitute the values into the formula. Where there's A, like I said, I'm going to put 1. Everywhere there's B, negative 5, and C, 6. So I have negative my B, which would be negative 5, plus or minus my B squared, minus 4 times my A times my C, all over 2 times my A. And then all I need to do is simplify this expression here on the right side. So when I simplify, I could get rid of these double negatives. I could work on this squaring and this multiplication and this multiplication. So 5 plus or minus 25 minus 24 over 2 is really going to be 5 plus or minus the square root of 1 over 2. And the square root of 1 is just 1, so I have 5 plus or minus 1 over 2. So really I have two scenarios here. I have x is equal to 5 plus 1 over 2, and x is equal to 5 minus 1 over 2. So this looks like my answer is going to be 3 and 2. So here's another example. 3x squared is equal to 6x minus 1. You want to set the equation equal to 0. You could either move this 3x squared to the right side, or you can move these two to the left side. Just out of habit, I would transpose 6x minus 1 to the left side. That's just me. So when I go through this, that's the way I'm going to end up doing it. So I'll give you a few minutes to work on this. I don't know about a few minutes, but I'll give you some time to work on this. And then we'll do it together. So in this example, I'm transposing my 6x and my negative 1 to the left side of the equation. And I could identify my A, my B, and my C coefficients. A is 3, B is -6, and C is +1. Now we just have to substitute these terms, these values into the formula. Once I substituted my formula, I want to look at these signs here. I want to square this. I want to multiply these. Now I could simplify what's under the radical here. I have 6 plus or minus. This will give me 24 all over 6. Make sure your fraction bar comes all the way across. 24 could be simplified, right? 24 is actually 4 times 6. So I could write it as radical 4 times radical 6, which is really 2 rad 6. So this is x is equal to 6 plus or minus 2 rad 6 all over 6. This could be simplified further. Sometimes in remedial math, they say, well, all 3 of these are divisible by the same value. So we could divide out a 2 from each one. So if I divide this by 2 and divide this by 2 and divide this by 2, we would have 3 plus or minus radical 6 all over 3, which is fine. But in reality, in math, what's really going on is we're factoring out a GCF here of 2, which would leave us with 3 plus or minus rad 6 all over 6. These are reducing, and we get the same thing, 3 plus or minus rad 6 over 3. This is really mathematically what's going on. This is kind of a shortcut that they teach in remedial math. This looks like example 3. 2x squared plus x plus 5 equals 0. Let's try this one. I'll give you a minute. So you want to identify your A, your B, and your C coefficient, and then substitute the values into the formula. So I have negative B plus or minus B squared minus 4 times my A times my C all over 2A. So I'm going to have x is equal to -1 plus or minus 1 minus 8 times 5 is 40 all over 4. X is equal to -1 plus or minus -39 all over 4. -39 is really 39 times the square root of 1, or radical 39i. So I'm going to write this as x is equal to -1 plus or minus, I like to put the I first, over 39 over 4. 39 can't be simplified, so that's my final answer. And again, I have 2 answers. It's -1 plus I 39, rad 39 over 4, and -1 minus radical 39i over 4. So you have both of those. My answer here, both answers are imaginary. And try this last problem. And that'll be the end of solving quadratics using the quadratic formula. I was muted that whole time. Thank you. Sorry. What? What did I say? All right, let's go through it real quick. A is 1, B is 2, C is 1. I substitute those values in. I get -2 plus or minus 2 squared minus 4 times my A times my C, all over 2 times my A. The negation of 2 gives me 2. 2 squared is 4. Minus 4 times 1 is 4, all over 2. 4 minus 4 is 0. The square root of 0 is 0. So really, I kind of have two answers. I have -2 plus 0 over 2, which will give me -1. And I have -2 minus 0 over 2, which will give me -1. So plus or minus 0 doesn't change it. We still end up with -2 over 2, which is -1. So we could say we have one solution, -1, or we could say we have two of the same solutions. Right? When we have a 0 underneath the radical, this will always happen. We'll have two of the same solutions. And then that's it for solving quadratic equations using the quadratic formula.